What happens when you suddenly choke off the lifeblood of modern artificial intelligence, when the most brilliant minds in tech are strictly denied the computing power they need to survive? Well, they don't quit, they innovate. Welcome to this explainer on DeepSeek V4 Pro. Today, we're decoding the brilliant algorithmic hacks that turned a massive hardware disadvantage into a revolutionary efficiency breakthrough. Cut off from high-end hardware, these engineers faced a brutal reality. They simply could not buy their way out of the problem. They couldn't just throw thousands of top-tier GPUs at a massive dataset and hope for the best. Instead, they had to think their way out. They literally had to strip the engine down to the studs and rebuild it to run on fumes. And that constraint created the hardware pressure paradox. International export controls actually served as the ultimate catalyst here, forcing an unprecedented focus on algorithmic efficiency over raw compute power. That leads us right into their first major innovation: reading like a human. A million token context window is typically a financial black hole. If you double the window in a traditional model, you quadruple the computing power, simply because the system tries to compare every single word against every other word. DeepSeek completely broke that math. They engineered a chunk and summarize method instead. Think about reading a massive, soul-crushing legal contract. You don't memorize the preposition in paragraph 2 to understand the conclusion in paragraph 10, right? You chunk the text, summarize it, and zoom in only on the clauses that might actually get you sued. The result is a sheer reduction in overhead. This brilliant approach slashes requirements, allowing the model to use just 10% of the memory demanded by legacy architectures. That isn't just a marginal improvement. That is an absolute paradigm shift. The second breakthrough systematically tackled processing overhead, using the hospital specialist architecture. DeepSeek boasts an incredibly massive 1.66 trillion parameters. But turning all of that on for a simple prompt, that's a colossal waste of energy. To fix this, they utilized a mixture of experts, or MOE architecture. The core philosophy here is brilliant. Build massive capacity, but selectively deploy it, so the model never fires all of its parameters at once. Think of it exactly like a hospital. If you walk into the ER with a broken arm, you need an orthopedist. You do not need a neurologist, a cardiologist, and a pediatrician all standing around your bed. DeepSeek functions the exact same way. The router looks at your prompt and activates only the necessary pathways, meaning only 49 billion parameters activate for any given task, leaving the rest completely idle. The financial impact of this routing is staggering. It drives the API costs down to an incredibly low $3.48 per million output tokens. Compare that to Claude 4.7 Opus running at $25. You are getting top-tier output for a fraction of the cost. The economic barriers to massive AI deployment just collapsed. But to build these highly effective specialists, they had to entirely rethink how they train them, moving to verifiable expert training. You can't just dump the entire internet into a single model and hope it naturally separates its skills. The engineering team was meticulous. They isolated models for specific tasks, like coding and math. Then they rewarded them strictly on concrete, verifiable outcomes, like successfully patching a software bug, and only then merged them into the final system. The model wasn't rewarded for sounding confident. It was rewarded for being right. And this constraint-driven ingenuity has directly resulted in near-zero cost engineering. When you combine hyper-efficient architecture with ruthlessly verifiable training, the output literally speaks for itself. On the Sweetbench coding test, V4 Pro scores a dominant 80.6%. This test gives the AI a raw, messy GitHub issue and demands a working patch. DeepSeek is executing this at a level previously reserved for the most expensive frontier models in the world. We most transparently note the caveats, however. Independent testing shows its broad general intelligence and open-ended safety layers still lag 6 to 8 months behind Western models. If you want abstract reasoning or beautifully nuanced creative writing, this isn't the apex predator just yet, and its safety guardrails are notably less robust. Yet that really doesn't dull the impact of what they've built here. Because this model is fully open weight and completely free to download, the developer community is already swarming it. You are left to grapple with a profound reality. What happens when you unleash near-zero-cost software engineering capabilities straight onto your local machine? The barriers to creating software are no longer financial. They are purely imaginative.